Hey everybody, let's get straight into it. We're going to do some trigonometric graphs today, and it is going to be so much fun. It's time for math with Mr. Troy. What can I say? Alright folks, we're talking about graphing trigonometric functions. First of all, the sine function. We talked about this in a video before, but that the sine is 0 at the angle 0. The sine is 1 at the angle pi over 2. The sine is 0 at pi. The sine is negative 1 at 3 pi over 2. And the sine is 0 again at 2 pi. If we wanted to fill that in at pi over 4, it would be root 2 over 2. Same thing at 3 pi over 4. It would be negative root 2 over 2 at 5 pi over 4. And at 7 pi over 4, it would be negative root 2 over 2 again. That is your sine curve. Okay. There are kind of two new things that I want to think about, and then we'll move on to the next slide. First of all, you are going to identify the sine curve by thinking about just 5 points. The 5 points you are going to think about for the sine curve are going to be middle, high, middle, low, middle. I will explain what that means, I promise. That's also going to correspond to the unit circle. I want you to think about the unit circle for a second. We've got 0, we've got pi over 2, we've got pi, we've got 3 pi over 2, we've got 2 pi. These are the 5 positions that we're going to think about. Middle, high, middle, low, middle. On this graph, right here, and here, and here, and here, separates the x-axis of a trig graph into the 4 quadrants of a unit circle. So this would be the stuff that happens in quadrant 1 of the unit circle, quadrant 2 of the unit circle, quadrant 3 of the unit circle, and quadrant 4 of the unit circle. Okay, so stop, think about how much of that makes sense, and write down any questions that you might have for our class, later today or tomorrow or whatever. Okay, stop, write down, what in the world is he talking about? Movie magic. Okay, while you were thinking, I went and I filled in, or I drew out that graph. I have to do that when the video is paused because it takes me like 7 tries. Okay, every graph of a sine curve you are going to make is going to fit this pattern of middle, high, middle, low, middle. Every time we graph, we're going to think about where the graph starts, where it goes up to, returning to the start, where it goes down to, and then returning to the middle one more time. Okay, that'll make a little bit more sense when we get some practice, but that's something that you have to memorize. Now, the great thing about the sine curve is that it repeats indefinitely. So if you want to graph more of it, you just copy it over, and you've got the exact same graph repeating in every direction. Okay, and we talked about that, of how that gives us our general solution and things like that. Cool, let's move on. So what we just graphed was the parent function of the sine graph. Now, the sine graph has a domain of all real numbers because you are able to take the sine of any angle. The range is from -1 inclusive to +1, because the only ratios you can get out are things between -1 or +1, and including those as well. The period is 2 pi. Remember, the period is how long it takes to repeat. The name for any function that repeats is a periodic function, and the period is how long that takes. A trigonometric function is a type of periodic function. Okay, the x-intercepts occur at pi n, comma 0. Obviously, for n is an element of the integers. Pi n just means any n value you pick, any integer, there will be an intercept there. So at 0 pi, at 1 pi, at 2 pi. The y-intercept is 0, 0. This graph goes through the origin. This has odd symmetry. So what that means is that f of the opposite of x equals the opposite of f of x. Now, let's see if we remember what that means, and let's see if we can show what that means for this particular graph. Okay, remember, what odd symmetry means is if you pick a point on the curve, across the origin, there will be another point. So, if you had, say, the point A, comma B, you would also have the point the opposite of A, the opposite of B. Put a little bit more formally, because we do have to know this sort of stuff. If f of A equals B, then that implies that f of the opposite of that is the opposite of f of A, which is the opposite of B. Okay? So that is our sine parent function. All right, so here is the cosine curve. You will notice it starts at 1. Now the reason it starts at 1 is because at 0 radians, the x-coordinate is 1. The thing that the cosine talks about is how far to the right or to the left of the origin is your given point at that angle. So, if I pick pi over 4, root 2 over 2, comma root 2 over 2, that x-coordinate represents the cosine of the angle. Okay? Our pattern for this one is starting at 0, 1, high, middle, low, middle, high. Again, let me show you what that means. It means that the graph is going to start at its top, go to its middle, go all the way down to its bottom, back to its middle, and then all the way back up to its top. Now, this might be different for different graphs. If I multiply the graph by 2 and shift it up 2, then this high is going to be different, but it's still going to be the same pattern. Okay? That is our cosine curve. And here is the cosine parent function. The domain and the range are exactly the same for a reason we'll come back to in just a second. So the domain is all real numbers, and the range is from -1 to 1, inclusive. The period, again, for the parent function is 2 pi. The reason that this is the same is because of the co-function identity, which says that the sine of theta, remember, we'll jump back and forth between using theta and for using x, just if we want to use the Greek letter, if we want to use x, the variable we used to. But I digress, equals the cosine of, and there are two ways to say it. You can either say pi over 2 minus x, or x minus pi over 2. Two different ways of looking at it, but they end up being the same thing. The x-intercepts for this are going to be pi over 2 plus pi n for n an element of the integers. And the y-intercept is going to be 0, 1. This has even symmetry. Again, let's make sure we talk about what even symmetry means. Even symmetry means that the function is reflected across, or symmetrical across the y-axis, which means if I pick any random point, there should be a corresponding point across the y-axis. The way we write this is that f of the opposite of x equals f of x. If I have some random point a comma b, I should also have a point opposite of a comma b, for the same reasoning as we had on the last slide. If you look in a textbook, you might see a sine curve or a cosine curve summarized like this. Go from 0 to 1 to 0 to negative 1 to 0, and that's your sine curve. Figure not necessarily drawn to scale. And for your cosine curve, go from 1 to 0 to negative 1 to 0 to 1. I would say exactly the same thing, except I would say middle, high, middle, low, middle for the sine, instead of saying 0, 1, 0, negative 1, 0. Okay, so that's how we're going to think about it, just keying into those 5 points. Okay, so say I want to graph something like this. Y equals 2 times the sine of theta plus 1/2. Here's the good news. You guys already know how to do all of this from the parent function because you've been paying attention all year. This graph is 2 times as tall as the parent function. There is a vertical stretch or a change in amplitude. So it's going to go from 0 to 2 instead of from 0 to 1. Then the graph is going to have its midline shifted up by half a unit. So normally the graph is centered around the x-axis in terms of its amplitude. It goes from 0, its middle, to 1, its high, to 0, its middle, to negative 1, its low. But in this case, it's going to be shifted up by a half a unit. So the first thing you should do when you're making a graph after you've labeled the axes is you should plot your midline. Then you should also think about how high the graph will go from there and how low below that midline the graph will go. So normally the parent function goes up from 0 to 1. So in this case, we're going to go up double that, or 2 units. So we're going to go from 1/2 to 2.5. And for now, I'm going to mark that on my graph. You don't have to do this. It's just something that I find helpful. And I'm going to go 2 units below my midline, which is to like negative 1.5. And I kind of think of this as, if you remember middle school, or no, not middle school, elementary school, where you learned how to write on handwriting paper. I think of this as your baseline and this is your midline, just like you would with handwriting paper. You know, like if you were going to write math on handwriting paper, that sort of thing. You know what I mean? Good. I'm sure you know what I mean. Okay, so the sine function normally goes 0, 1, 0, negative 1, 0, but we're not going to think about it that way. We're going to think of it as going middle, high, middle, low, middle. So the normal sine parent function, except twice as tall and shifted up half a unit. And you might be able to draw it a little bit better, a little bit neater than I am. But I definitely forgot to pause the video and draw it while I was off screen, so I just had to go through it. Okay, so that's the idea. We're going to find our midline. We're going to figure out how much higher than that our amplitude will take us, and how much lower than that our amplitude will take us. Okay, so here's one for you to try, and then we'll talk about it in class, and we'll answer any questions that you might have. This doesn't involve any of a horizontal stretch or shrink yet, or a horizontal shift, a phase shift. That's not yet. This is just to see if you can figure out what's going on. And then these other two are the remaining things that we need to talk about, the horizontal stretch and the horizontal shift, which we'll talk about after we make sure you know how to do all this. All right. Thanks for watching. It's been great. Hang tight. We are almost done with the school year. Oh, weird. Bye.